Students, today we will discuss 50th group of elements, which is also known as nitrogen family. In this particular lesson, some important questions and which are expected from the future entrance exams. Coming to question number 1, in nitrogen family, the HMH bond angle in their hydrides gradually becomes closer to 90 degrees. What is the reason for this? That is the question. Talk about HMH bond angle is saying, either we consider in this particular NH3, phosphine, orosine, stibine you take, stibine. Here it is found to be nearly 107 degrees. This is around 94. This is around 92. This is around 91 degrees. Why there is decrease in the bond angle? That is the question. So top to the bottom, they are all involving actually sp3. Top to the bottom, the sp3 hybrid orbitals, the atomic size is increasing. The atomic size is increasing. The sp3 hybrid orbitals character is decreasing. sp3 hybrid orbitals character is decreasing. So pure p orbitals are actually involving in bonding. Therefore, top to the bottom, the bond angle is coming to be near to 90 degrees. Let us see the options. The basic strength of hydrates increases. There is no relation between bond angle and basic strength. Coming to B, almost pure orbitals are used for MH bonding. So top to the bottom, what I said, the pure p orbitals are, the participation of p orbitals increasing, I said. Coming to C, the bond energies, there is no relation between bond energy and bond angle. Coming to D, the bond pairs of electrons are become further apart from the central atom. That is also not the suitable reason. Only the reason is what? The sp3 hybrid orbitals character is decreasing and atomic p orbitals are involving in bonding. That is the suitable reason for this question. Therefore, the question number 1 answer is B. Question number 2, most acidic oxide is. Option A is given as what? Arsenic oxide. Arsenic oxide. Option B is given as what? P2O3. Option third is given as what? Sb2O3, Sb2O3, Bi2O3. Question is that which is among these most acidic. Acidic means there should be a non-metallic oxide. This is what? Metalloid, arsenic. This is also metalloid. Bismuth is what? Purely metal. These two are metalloidic oxides. They are amphoteric in nature, not much acidic. Coming to phosphorus trioxide. Phosphorus trioxide is what? Non-metallic oxide. Moreover, suppose you are talking about P2O3 with water, produce what? Phosphorus acid. As it is producing with water, acidic solution, a acid it is producing. Therefore, among the given A, B, C, D, for second question answer is only answer B. Question number 3, when lead nitrate is heated, it produces. Let us see what are the products. A is given as NO2, B is NO, and C is N2O5, and D is what? N2O. These are the options. Let us see lead nitrate. Lead nitrate on heating, look here, it is actually decomposing to produce 2 PbO, 4 NO2 plus O2. The product is actually NO2. So here NO2, NO, N2O5, N2O. Therefore, the question number 3 answer is A. Coming to question number 4. Question number 4. Rainwater sometimes contains ammonium nitrate because lightning in the sky causes the air to react and produce oxides of nitrogen, and lightning, nitrogen and oxygen are combining. What are the options given? Check it. A, hydrogen gas. B, ammonia gas. C, CO2. D, noble gases. During the lightning actually N2 plus O2 lightening nearly 3000 degrees centigrade, then you are getting NO. Along with this particular NO, there is a formation of trace amounts of N2 combined with hydrogen producing ammonia gas also, producing ammonia. N2 plus H2 combining, giving rise to ammonia gas. Some amount of, little amount of ammonia is also formed. This is also possibility of formation of ammonia. Therefore, rainwater sometimes contains ammonium nitrate because lighting in the sky causes the air to react and produce oxides of nitrogen and ammonia. Once ammonia is produced, ammonia reacts with again nitrates or the HNO3 formed in the atmospheric air. Then ammonia reacts with the HNO3 forming ammonium nitrate. Therefore, question number 4 answer is B. Question number 5. Which is the most thermodynamically stable allotropic form of phosphorus? Among the allotropic forms of phosphorus, different types are there: red, white, black, etc. Which is thermodynamically more stable? Coming to option A, red phosphorus, white phosphorus, black phosphorus and yellow phosphorus. So, only black phosphorus actually possesses layered structure. It resembles structure with graphite. It is thermodynamically more stable. Allotrope of phosphorus is black phosphorus. Possesses layered structure, resembles graphite structure. So, it is also a conductor. So, question number 5 answer is C.